All right, this is the beginning of the solutions for homework set 9 in Physics 211. I'm going to give a short intro here. Most of the other ones will be recorded with that intro. I plan on doing solutions for every recitation problem and every homework problem for the rest of the term. This will be a lot of work, but I hope you all find them useful. I'm going to talk through the thought process behind all of the questions, and in the process, hopefully review all of the major concepts from this unit. So let's get started. So the first problem is asking us to think about um, under what circumstances work is zero or non-zero. So let's get started. So A, explain why the tension and the string of a pendulum does no work. So a pendulum might be something like this, where there's a little object on the end here, and it will swing back and forth. The thing that you need to realize here is that the string is perpendicular always to the path of motion. So this way is the force of tension, but at that point, instantaneously, the motion is that way. So if you remember the definition of work, if the force is constant, it's force dot displacement. If this is constant, or you may have to do an integral if it's not constant. But in this case, this is the insight here, the dot product means that F dot delta S means that this is the component of F parallel to delta S times the size of delta S. And in this case, there is no component of F parallel to delta S. F is always perpendicular to the displacement, so the work is zero. This is a general rule that's very important to keep in mind, that a force that is perpendicular to the direction of motion does no work. All right. Part B says, explain why the normal force does no work on an object sliding down a ramp. This is exactly the same logic. Part B. Here's an object sliding down a ramp. We can make the ramp any shape we like. So here's some ramp. But at any given place on this ramp, we'll be moving this way. The normal force will be that way, and again, this is a right angle. Again, the force is, I can't spell late at night, is always perpendicular to delta S, so the work is zero. Part C. Give an example of a situation where tension does do work on an object. These examples can be very, very, very simple. An example where tension does work on an object. If you lift a bag with a string, then the tension is in the same direction as delta S, so the work is positive. And question D, part D, says give an example of a situation where friction does positive work on something. Positive work, again, where friction causes something to speed up. Correcting my writing here. Remember, work is the change in kinetic energy. So here for part D, well, friction makes things speed up. Traction is an example of that. Or it can be. Traction from the wheels of an accelerating bicycle. So that's problem 1.